So this is basically a quick update on what we've been doing at King Edward School in Stratford. So as you can see from the front slide, we've been building lots of UKMARSBOTs, which is great news. We met every Tuesday after school for an hour and a half with 10 people or 10 pupils from Year 8 building line followers. And we had a couple of helpers from Year 11 who'd in previous years had some Arduino line following experience as well, with sort of previous robot clubs I'd run there. So in basically about just over a year ago, we started the idea of building UKMARSBOTs with the Robot Club. And then sort of really between then and December, we were doing both hardware builds and also in parallel getting people used to the Arduinos, because most of them had never done any Arduino programming before. From January through to March was sort of improving building the line following code and testing and trying to improve it. But we also have a 5-meter drag race strip. So we spent quite a bit of time sort of doing drag race as well, because I found that quite good fun. Then, as we all know, middle of March, lockdown came. So nothing happened basically through the whole of the summer. And then in October, we basically got 1 week after half term before we were locked down again. So we didn't get the opportunity to run the mice at Hazelmere, but what we have been able to do since Duncan posted out the UKMARSBOT track, we've actually run a number of the mice on that. So we've got at least some experience now, and we can show you a little bit about what's happened with those. In terms of where we were working in the design and technology lab, where we had a laser cutter and some 3D printers, and we used the 3D printers to make the wheels and the rear skids. We had 5 soldering iron stations, but 10 people building robots. So basically in each session, we had to sort of swap with 5 people building robots and 5 people getting used to Arduino, and then halfway through, we'd swap over. I think they all really enjoyed the soldering, as it was new to most of them. We had 10 desktop PCs in the DT lab, and we managed to get Arduino loaded onto them, including the CH340 driver that we needed for the Arduino Nanos. And I also set up a website with the build instructions, some Arduino advice, and some little bits of sample code. In terms of the builds, we used the Pimoroni 20-to-1 geared motors, which basically gave us more top speed than they could control. So, we didn't actually need anything faster than that. We didn't put encoders on because it was going to be complicated, and we thought we'd get the basics sorted first, and it was expense as well. We were using visible light sensors for safety, and we used O-rings on the tires for the printed wheels. Okay. We didn't have a big track to try things out at the school. We had some blackboards that we put some white tape on, and the boys liked ripping the tape off and putting different tracks down and things. But basically, we used a small 57 by 72 centimeter track with just a circle and some lines on it, just to try things out. Some things went around that reasonably well once they've been built, and others not quite so well, which is about what we'd expect. Once we got them running on that, as I say, we did go on to then do stuff with drag race. But here's a shot of one of the better school line following robots running on the track that Duncan has sent out. And as we can see, it's follows the line nicely. It does the crossovers pretty well as well, and even the tight bends, it's following the track round pretty well as well. It didn't do sort of, full PID control. I think there might have been a little bit of proportional control in this one, but that was about it. But in spite of that, I say the best ones, with a bit of tuning on the speed and with not trying to run too fast, got around the track pretty well. So once we'd done a bit of line following, as I said, we went on and we tried a bit of drag race type stuff as well. And again, here's a couple. This one, he was trying to go a bit too fast and wouldn't quite stay on the line. And there's always a question of balancing speed with control on the drag race track, and especially since our track is actually a Teflon track, so it's pretty slippery. So you needed to be controlling it well to keep on the line. Here's a slightly better one. In fact, this is one of the best ones. And this one actually goes right the way down to the end at quite a decent speed, and stops correctly at the end as well. That was something it took quite a bit of work to get them to work out how to do the stopping at the end and sort all that lot out, but a few of them managed it at the end, which was good. So in terms of the one that I built, because I built one as well as all the 10 being built at school, in fact I built a couple. I built one with the 10-to-1 geared motors just to see what it could do, and I put some proportional and differential control on it, but it still at this stage wasn't using encoders, and although it has the extended line sensors on it, it's not detecting those and trying to use those to go faster down the straights or anything like that. But again, nice smooth run. I don't know how it's showing at your end, but at my end, this is a really smooth run around the track as it comes back round. And again, it's a little bit faster than the ones from the pupils at school. It's around the track in 19 seconds, but there's still plenty of scope for more improvement, running it faster, and particularly doing the use of the radius markers to decide when it can go faster and when it should be going slower. In terms of some of the issues and problems we had, the Arduino software, you have a couple of options when you're loading up the programs, and with quite a few of the Nanos we had to use the old bootloader option, which presumably means it had some slightly different bit of hardware on the Nano itself that was reading the stuff coming in from the USB, but we managed to sort that out. But it did mean that whenever you plugged one in, quite often you would try and load it up and it wouldn't, and then you'd think, oh well, I'll try this one with the old bootloader, and it would usually work then. We started with using externally recharged lithium ion batteries. The ones shown on the right there are the ones we reused, and they worked really well, but we wanted the boys to be able to do some stuff at home, particularly sort of during the holidays and things. So I got a whole load of these OK cell ones that you can plug a 5-volt charger into, but they were absolutely useless. So if you know anybody who wants a use for 10 of these, that you can have them at a very reasonable price. Basically, as soon as you put a significant load on this, the thing started off, the voltage dropped so low that the Nano just reset. So it wasn't any good at all on those. So we've had to swap back to using the externally charged ones, which means that since we've only got a couple of chargers, each of which charge up 4 of these batteries at a time, it means we couldn't sort of give one to people to use them at home. In terms of the build, soldering where things were very close together was always a little bit of an issue, with people soldering for the first time with old soldering irons that weren't that brilliant, and they were a little bit on the large side. Particularly the wires. We did wires from the main board to the line follower board. Those we quite often got the odd short across those, which was not good. Also on the little resistors right at the back under the battery that drive the 4-pole switch, we quite often got some of those shorted out together, or what was more of a problem, when they were soldering one resistor in, they would block up the whole of the next one, and those were particularly difficult to then get unblocked, but we did manage to do that. So we got around all these problems as we got them, and we got all of them built, which was good, and all of them were running quite well. As I say, we had a look at sort of whether they were seeing the side markers, because ours weren't sort of pointing out so much as Ian's were, and I've put Ian's extensions on mine just to try it out. I've also replaced the wires on mine with just a little VeraBoard connector, which again is connected to the line follower board and just plugs directly into a socket on the main board. Right, so what happens now? I'd hoped we were going to be able to build more wall follower boards and do wall following and other stuff as per the wall following board shown on the diagram there. And again, I put a VeraBoard sort of connector interface on that one. But over the summer, I said people could take their robots home, because basically we said they could keep them. About half the boys took their robots home, and one or two of them did a little bit with it. One of the guys went back to India, so one of them's over in India at the moment. But with this term, all the boys are doing Python on Raspberry Pis in their computer technology class, and so they wanted to do a Raspberry Pi based competition this year. So we've taken the same boys that have done the UKMARSBOT, and 6 of those were building a single robot for the 6 or 7 challenges in the Pi Wars at Home competition instead this year. Okay, that's about it for me.